Hello everyone, welcome to this video on learning mathematics through concepts and examples. In this video, we are going to learn U substitution for definite integral. So we are working on U substitution. Okay, we are working on U substitution and we are going to use this technique to evaluate the definite integral. So here we have the question. So here you can see we are asked to evaluate the definite integral from 0 through 1. And the function here is x over the square root of 1 plus x squared. We're integrating that with respect to x. Now, if we look at this carefully, we can see that, okay, if we look at this, we can see that in the denominator, we have a composite function, right? The outside function is a square root function, and the inside function is 1 plus x squared. Now, in U substitution, what we do is we look at the derivative of the inside function. So if you look at the derivative of the inside function, the derivative of the inside function will be 2x. But here we only have x. So what we do is we multiply there by 2 because we are looking for 2x. So we multiply there by 2 and also we divide by 2 so that, okay, so that we can easily use the U substitution. But I'm going to write that in new steps. So let me write, let me begin from here. So here we have integration from 0 through 1, x over this. Let u equal to inside function 1 plus x squared. 1 plus x squared. Now the derivative of that function with respect to x is equal to 2x. Or the value of du, if I multiply on both sides by dx, du will be equal to 2x dx. So we are going to make that substitution here. So if we do that, you'll see that we are integrating in the denominator, we have 2 times the square root of u because 1 plus x squared is u. And then in the numerator, I have 2x dx. So 2x dx is from here, 2x dx is du. That is equal to du. Now, these are the limit of integration in terms of x. But I need the limit of integration in terms of u because here I'm integrating with respect to u. So that means when x equal to 0, if you look at this equation here, when x equal to 0, u will be equal to 1 plus 0 squared, which is 1. And then if x is equal to 1, 1 plus 1 squared, that is a 2. So we are integrating from 1 to 2. So as we are integrating with respect to x, we have the function in the numerator, I have a 1 over 2 square root of u. So the integration of that is equal to square root of u, because the derivative of square root of u is 1 over 2 square root of u. So the integration will be square root of u. And we have to evaluate this between 1 and 2. We have to evaluate this between 1 and 2. So let's see. If I plug in upper limit, now we need to evaluate this using the fundamental theorem of calculus. So if we plug in the upper limit, we get a square root of 2 minus, if I plug in the lower limit, we get the square root of 1, which is 1. So the value of the definite integral is square root of 2 minus 1. So this technique of evaluating the definite integral is using the U substitution. Remember, U is the inside of the composite function, and there should be the presence of the derivative of that function in the given integral. And once you make that U substitution, remember you also need to change the limit of integration because the original function is given, or original integral is given, and we are asked to integrate with respect to x. So the limits are in terms of x. Now, after we make the U substitution, the limits should be in terms of u. Okay, that's all from this video. I hope you find this video helpful. Thank you so much for watching.